Hi everyone. So for today's session, in the first part, we'll be talking about EC2, wherein we get virtual servers using this service in AWS cloud environment. And within EC2, we'll be understanding various terms such as AMIs, which are Amazon Machine Images. We'll also be talking about security groups, key pairs, and the tenancy attribute. And then on the network side, we'll see what is the underlying network layer on top of which your EC2 service is built. We'll start off with EC2. So EC2 is a service that provides scalable virtual servers in the cloud. And these virtual servers in the AWS environment are referred to as instances. And they can be made up of different instance types and sizes. So by instance type and sizes, I mean that it describes the hardware component that an EC2 instance would run on. So this would include your number of processes, amount of memory, network performance, and so on. And within EC2, the service is highly scalable and you can opt in for pay as you go model. So in the later part of the session, we'll talk about various purchasing options that are available within EC2. So the most commonly used one is pay as you go. And there are other options available wherein you get significant discounts if you put in a commitment for a time duration and you're willing to pay some upfront cost. The full form of EC2 is Elastic Compute Cloud. So coming back to various instance types, so as I said, we specify the various hardware components that your instance would run on, and that would include your processors, memory, network performance. So as a solution architect, it's very important to use the proper instance type to handle your application's workload. There's a predefined collection of instance types that are grouped into families and types that you can choose from. And very shortly, we'll see that in the demo. So a couple of benefits of EC2. I'd been performing demos wherein I was able to spin up a virtual instance in under 2 minutes. So it's pretty easy, flexible, it is scalable. So in isolation, the scalability is not achieved. So I believe in the next session, when I talk about auto scaling, that is part of the EC2 services, you can achieve the scalability aspect wherein you can automate the entire process. Let's say you have defined a threshold that if the traffic exceeds X percentage or CPU utilization exceeds X percentage, you can spin up more number of resources. Service is fully reliable in the sense, if you do it right, if you configure it right, you will see known downtime. So recall we have this first session, we had said that your workloads should be distributed across multiple availability zones. So define health checks if even if an instance goes down, a new instance can come up on the fly and you can set it up in the operational state. With respect to security, there are tools and methods available in form of security groups so that you can filter both incoming and outgoing traffic. And it is inexpensive, so you go by an hourly rate. So that way, if you want to do a test for a couple of days, just pin up the instances for a couple of days, and that's about it. And you only end up paying for that period. So in the context of EC2, the first term that we need to be aware of is AMIs. AMIs stand for Amazon Machine Images. So Amazon Machine Image is actually a template that is required to launch a EC2 instance. And the template includes the information such as operating system, any application software packages on top of that particular operating system. So that's the prerequisite. The first step of provisioning your instance is to either pick up an AMI that is available with Amazon, or you can create your own AMIs. So I've logged into the AWS console and we'll go to the EC2 dashboard. So EC2, first of all, is a region specific service. So make sure you are in the right region in which you want to provision your virtual servers. And as I said, you can pick up AMIs either from Amazon. So there are multiple options out here. So during the launch process, as a first part of the process, you'll have to select an AMI. So there's a quick start section, which includes the most commonly used AMIs. So you have Amazon Linux distribution, and it would give you the details, what are the application packages on top of this operating system. So for most part of it, we'll be using Amazon Linux AMI. And in this case, it has Python, Ruby, Perl, and Java already pre-baked into this template. So likewise, there are a set of AMIs that are available, and please note that only pick up the AMIs that are eligible for free tier. Then you have My AMI section. So these are the custom AMIs that you can build. So either you can build your own AMIs, pick it up from the quick start section. And additionally, there are a lot of options available in the AWS marketplace. So it is very similar to your Play Store and App Store, wherein you get a lot of options available. So for example, you are looking for an endpoint protection software. So you already have a pre-baked AMI for it. So over and above the cost of the EC2 instance, usage of this AMI would cost you like 1 cent per host per hour. So there are good number of options available. So let's say you want to find Tableau, which is a BI tool. So you have most of the options available out here. So in a rare case, you don't find a software appliance in the quick start or in the marketplace. So what you can do is you can purchase the license on your own and use that license on top of your EC2 instance. So using this template in one go, you can actually launch as many number of instances that you may want to launch. So every account comes with a soft limit wherein Amazon would simply not allow you to launch 100 instances at a given point of time. That's simply because to prevent accidental misuse. So there are soft limits on your account, and I'll come to soft limits again once we get into the demo part. With respect to security, we have security groups that operate at the compute layer or at your instance level. So security groups, they act as a virtual firewall that control what traffic, both incoming and outgoing traffic. So in this case, all what you need to do is you need to specify within the security group that for which protocol, which port number, what is the source and what is the destination that you want allow the traffic to be allowed. So in security groups, you can only specify allow only rules. And instances within the same security group, it depends on the configuration whether you want them to communicate or not. So it's up to us. And these security groups internally, they are applied to the network interface of your compute resources because your network interfaces form both entry and exit point for your compute resource. So the process to create a security group is very straightforward. So let's see that in action. So I can create a security group during the instance launch process, or I can create it beforehand. So the option is purely with us. So let's say I want to create a security group for my instances in the web tier. So I'll give it an appropriate name, WebSG. I'll have to specify the rules. So I'll have to specify the type. So in this case, let's say I want to allow SSH access to my instance. So SSH works on port 22. I have to specify the source address from which I want to allow this SSH connection. So you have custom anywhere my IP. So for demo purposes, I'm saying anywhere, but in real-time scenarios, you make sure that you make it custom. And the second rule that I'm adding, since the security group would be applied to your instances in the web tier, so I'll be allowing HTTP traffic as well. So the rules that I just set up in this security group, these are inbound rules, and by default, all the outbound traffic is allowed. So we can change that, but this is the default behavior. So in this context, outbound would mean any traffic generated from within the instance to outside that instance. So now it could be to another instance, it could be to an internet resource. So it is a resource outside that instance. So the illustration that what we have out here, this is to see a firewall out here wherein that controls the traffic. So a good example, I can give you a better architectural representation with respect to security groups. So this is a three-tier architectural representation. You have web, app, and database tier. And this tier is associated with one security group. This tier is associated with another security group. And my database is again associated with third security group. So in this security group, I'm controlling the traffic that is coming from outside. Likewise, for app server, I can control the incoming traffic only from the web servers. And likewise with the database servers, I can control the traffic only generated from app servers. So one of best practices is include security at every layer of your application. So at the compute layer, you should be using security groups to control both inbound and outbound traffic. And lastly, security groups are stateful. So stateful in this context means that any traffic that is allowed in the inbound rule, the return traffic would be allowed by default. So regardless of whatever the outbound rule says. So we'll see that in action very shortly. So there are other representations as well. This could be considered as a web or rather web tier, and they are spread across multiple availability zones and they are part of the same security group. At the network layer, again, you can have access control lists that would further filter the traffic to your compute resources. So in the illustration that what we see on the screen, again, we have a three-tier architecture. So web tier, this could mean X number of my virtual servers or instances, and application tier again can have X number of instances, and likewise for database. So we are opening for web tier, we have opened ATN 443 if you have configured SSL. For application tier, again, you'll open up connections from web tier. And additionally, you might want to open SSH connection for you to access the instance directly. The next term that we should be familiar with is key pairs. So EC2 key pairs, they are cryptographic secure keys that are used by AWS to authenticate a client when logging into a EC2 instance. So it's a combination of public and private key, and collectively they are referred to as a key pair. AWS stores the public key on the instance and the end user gets to download the private key. So to log on to an instance, let's say if you are using Linux instances, so by default, they have no password. You only use the key pair to log into Linux instance. And for Windows distribution, you use a key pair to obtain admin password and then log into the Windows instance using RDP. So during the creation of EC2 instance or otherwise as well, you are required to create a new key pair or use an existing key pair that can be tied to the instance. So the idea here is to provide a secure mechanism to connect to your instance. So let's go back to the EC2 dashboard, and just below security groups, you have key pairs. So you can import a key pair or you can create a key pair on the console directly. So I'll create a key pair, and so now AWS would generate a public key and a private key. In fact, it has already started downloading the private key pair. When we provision our instance, we'll have to associate a key pair with the instance, and AWS will associate the public key with that instance, and I'll be using this private key SSH into that instance. So I've got this key, so I'll just save this key. So now we'll proceed with the demo on provisioning our instance. So this time we'll take it slow, understand various attributes associated during the provisioning of the instance. So make sure you are in the right region. Go to launch instances. The first step is to select the right AMI that you want to provision. And for the first part of the demo, I'll be using Amazon Linux AMI, and it is marked as free tier eligible. Next, you need to choose an instance type. So instance type, as I mentioned earlier, it is refers to the hardware specification in terms of number of CPUs, memory, storage, and network performance. So there are multiple families available. You have general purpose, then you have compute optimized. So general purpose offers you a right blend of compute and memory. Compute optimized, as the name suggests, would give you more compute power as compared to memory. Then you have memory optimized, GPU for if you have media workloads to operate with, memory optimized. Then you have storage optimized as well. So you have good number of instance types available, and you can always, let's say you picked up a wrong instance type and you want to either scale up or scale down, meaning you want a better configuration or probably a lower configuration. So doing that is always a couple of clicks away. So you don't need to remember these configurations per se, but have a generic idea that what are the various families available. So as the name suggests, for compute optimized, it would offer you better compute power as compared to other parameters. General gives you the right blend. So if you really don't, you are stuck, what should I choose? Go ahead and start with general. So make sure you select the one which is marked as free tier eligible, because that should serve the purpose for us. The next step is to configure instance details. So this is where you set up all the configuration parameters. So the first part is number of instances. So I can specify, let's say 10 instances out here. So it will use the same configuration to provision 10 resources for 10 instances or virtual servers for us in one go. Recall a while back I said that there are software limits on your account that are imposed by AWS. So that's simply because to prevent accidental misuse. So as a solution architect, let's say you're planning to do a rollout. So make sure that you check on these soft limits that are applicable to your account. So as it stands today, the limit on my account is 20. So when I had signed up, initial limit was probably one or two. So since this is a soft limit, all what you have to do is just create a ticket with Amazon, specify why do you need additional resources, and they kind of do it on the fly. So you can put in a ticket, right? You have a link request limit increase. So EBS falls under EC2, so this is where you would see EBS network limits as well. So the maximum number in my case that I can put here is 20, but we'll start off with one instance, the network parameter and the subnet parameter. I'll be talking in detail in the network section, wherein the network service allows us to build our own private virtual cloud. So at this point of time, we are using default network, which again is dedicated to my account. So earlier, what used to happen was when you sign up for the account, it was up to the customer whether you want to create a VPC or not. But for security reasons, over last several years, Amazon by default would create network environment for you, and that is like your private space in AWS. So it is up to us whether we want to use the private network built by Amazon or whether we want to build our own. So 9 times out of 10, if you talk to your network teams, you'll be building your own environment. And likewise for subnets. So subnets in this context refers to the availability zone that you want to use to provision your instance. You have a option here, assign public IP address. So by default, it is enabled. So for me to connect to this instance that would be provisioned, so how do I connect to it? So this machine needs to be associated with a public IP address. So I leave it as default. So I'll come back to these options in the second part of the demo, rest part of the. Next part is to add storage to this instance. This is elastic block storage, commonly referred to as EBS storage, that we are attaching to this instance, and this is a network storage. So this volume type is being referred to as a root volume. So root volumes are the ones on which you install your operating system and other application packages. So to start off with, we are attaching 8 gigs of volume to the instance that we are provisioning. Next, tags. Tags play a very important role, so help you identify resources. So you can add multiple tags. So let's say project ABC, you can add cost center. So whatever code, you could filter out the information based on tags, so to capture a lot of information. So let's say I want to capture what are resources being consumed by project ABC, I can do that. What is the total cost being incurred by resources in this project? So you can do that. So tagging plays a very important role. Next step is to configure security groups. So you could have created the security group at this point of time. The process is the same, or you can select an existing security group. So we had created a security group a while back. I'm adding the rules again. I'm creating a new one right now. And it gives you a warning message that you're allowing sources, so anybody can connect. The last step, review your configuration, what we have said in previous screens, and launch. So when we launch our instance, it would prompt us to choose an existing key pair, create a new key pair, or proceed without a key pair. So depending upon the level of automation that you have implemented, I've seen some organizations, they actually don't allow SSH access to instances at all. So they don't create a key pair. So both the options are available. In our case, we'll choose the key pair that we just created. That's about it. So the current state is pending. All the attributes that you see in the description tab, these are essentially configuration parameters that we supplied during the process. So it has picked up availability zone 2B. So we let Amazon pick up the availability zone for us. It has assigned a public IP address. So I'll be using this to connect to this particular instance. Lastly, the internal private IP address that has been assigned is the one that we see on the screen. Next, in terms of connecting to this instance, So if you have a SSH client or using a Mac terminal, you can directly do a SSH with the key that we downloaded from Amazon. Else, if you are using a Windows terminal that does not come with a default SSH client, I'm using PuTTY to connect. However, PuTTY does not recognize the file format that we downloaded. So we'll have to change the file format. So this is an optional step only for Windows users. So you download PuTTY, and there's another tool called PuTTyGen that you can use to convert the format. So I'm using PuTTyGen to convert the format. So please note this is a optional step only for Windows user trying to connect to your instance using PuTTY. So I use the tool to convert the format, and now we are good to go. So I'll be using PuTTY. So I'll just grab the public IP address of this instance. I'll have to pass the path of the private key file for authentication. So for Linux distributions, you don't need to supply a password, and the default username that we use to log into the instance is EC2-user. So I've been able to log into this instance, and I'll just upgrade my privileges. So what I'll do now is install web services. So now these commands are operating system specific. So depending upon your comfort level with any operating system, you can try this out. And if I try to access at this point of time, so since the web services are not running, I don't get anything. So this is the default page. So let's go ahead and change this default page as well. So we are good here. So we have seen how easy it is and the flexibility that the service gives us to provision instance within a couple of minutes. So now in this case, I actually had to log into my instance to perform certain steps, but there are ways to automate to get your instance into the desired state. So in the next part of the demo, we'll again launch a EC2 instance and we'll try to automate the process. So before we get there, let's check other options available at the instance that we just spin up. You have status checks. So two types of status checks. One is system status and instance status. So make sure that these two checks have passed before you actually start using the instance. Then with respect to this instance, you will see metrics like CPU utilization, disk read, networking, all the metrics that are associated with this particular instance. So the details that are available under the monitoring tab, they are actually coming in from the monitoring service, which is CloudWatch. And lastly, you have tags. So the tags that what we see here is what we set up. So I can add additional tags anytime. So I'm provisioning a second instance. I selected the AMI, and again, the family is general purpose. So in the third part of the step, so let's take a look at other options that are available. You have shutdown behavior. So an instance can actually be in multiple states. It could be in running. That means it's operational. You could stop it. So that means you are releasing the hardware capacity back to Amazon. So in that case, you will not be charged for the compute resource. But please keep in mind that you will still be charged for the storage component. So recall in the previous demo, we had attached 8 gigs of storage. So I'll not be charged for my compute resource, but I'll still be charged for the storage component. So a lot of organizations actually what they do is during their working hours, they'll start the instances and off hours, they stop the instances to save on cost. You can actually automate this entire process. And then the state is terminate, which means that you're releasing the capacities to Amazon forever. So you'll not get the same system state back. So you're releasing the capacity. So in termination, you have an option whether you want to terminate the storage component as well or not. Then you have an option of enable termination protection. So in this case, if you enable it, the users would not be able to terminate the instance. This is simply a preventive measure so as to prevent accidental termination of your resource. Then you have monitoring, which refers to CloudWatch service. So by default, CloudWatch offers two flavors. So one is basic monitoring, in which the metrics are captured at a 5-minute interval. And there is detailed or enhanced monitoring, which is a paid version where the metrics are captured at a 1-minute interval. So detailed monitoring is chargeable, whereas basic monitoring is free of cost. So for production environments, if you want to use CloudWatch, make sure you enable this. Tenancy attribute, I'll discuss it in a bit. Now we're trying to automate the process to get the instance into the desired operational state. So in this case, I'm just repeating the steps that I performed after logging into the instance. So I'm passing this as a user data. So once the instance is in running state, it would execute these commands and get my instance to the required operational state. Next part again is adding the storage to this instance, and you have an option of delete on termination. So this is where you can decouple your storage component with your compute resource. So if I uncheck that, so when I issue a terminate command, only my hardware resources would be released. My storage component would still be available to us. So I can use that with another instance or for any other purpose. So I'll be using the same security group that we created earlier, since this is again part of the web tier. I'll associate the same key that we created a while back. Various attributes associated with the second instance that we have provisioned, but as associated with a public IP address, likewise it has a DNS name. So we can either use the DNS name or the IP address directly. So now for the second instance, I actually did not have to log on since I had bootstrapped the instance. And we are assuming that this state is the operational state for this instance. So there are multiple ways of approaching to this, wherein do it yourself, wherein you provision an instance, log in, get it to a desired state, automate the process. Bootstrapping is the first step in doing so. And as we move ahead, we'll be talking of various other tools like Beanstalk, Opswork, CloudFormation that further help you manage resources as a group of resources. So the next step is creating your own custom AMIs. So let's say the instance that we just created is the one that we really want. That serves as a baseline for us for provisioning further instances. So we can go ahead and create custom AMIs. So go to images and create an image. So on the left hand side of the pane, you have under images, you have AMIs. So this would indicate all the custom AMIs that you would have. So it actually depends on the size of your instance, and it's relative to time it takes to create the image of it. Okay, till the image comes up, with respect to storage, we can take a look at volumes. So we have two instances available to us and we're using two volumes. These are indicated in the volumes tab and the state indicates they are in use. So now the status is available. That means the AMI has been created. So now if I was to provision an instance, I can use this AMI as my baseline to provision it. So rest part of the process is pretty much the same, wherein you select the instance and various other configuration parameters. So this is my baseline instance. So meanwhile, I'll go ahead and terminate the instance. So this is the instance that we just provisioned. So again, we have this instance ready in the desired operational state. So custom AMIs is one of the methods that you can use to set up baseline image for your specific component of your application and could be used as backup method also. So in case something was to happen to my compute resource, I can use this AMI again to provision a new instance. So we have already seen that the provisioning of instance happens like under 2 to 3 minutes. So this is good for environments with less dynamic release cycles, wherein I've seen organizations doing multiple deployments as of today. So maintaining AMIs in those cases would be an admin nightmare. So depending upon your specific use case, if the release cycle is less dynamic, you can use the AMI approach, or else we can use different other tools or build in automation to mitigate the effect of the an outage. So I'll just quickly connect to one of the instances. Let's connect to Web 2. So what I'm trying to demonstrate here now is user metadata and instance metadata. So in the first part, we'll be looking at user metadata. So this is essentially the script that we supplied during the boot process. So that would be visible to us. So this is the user metadata, essentially the configuration or the script file that we supplied during the boot process. The second one is the instance metadata. So this is information about the instance itself. So the attributes that what we see in the description tab, if I want to check these attributes at the instance level, I can refer them using instance metadata. So these are static URLs. So 169.254, 169.254. This is a loopback address that is assigned to every instance. So this would always remain the same. So if you had to check the user data or instance metadata, you'll be using this. In this case, you see all the attributes that are available at the instance level. So for example, you want to check from your instance, what is the public IP address available or assigned to this instance, you'll get to know that. So if you want to check the details about instance attributes, you'll look out for instance metadata. And if you want to check the script or series of commands supplied during the launch process, you will look out for user metadata. So I have given you both these URLs. So these URLs would be applicable across all the instances. So the next thing that what we'll do is we'll analyze the stop behavior of when we stop the instance and start it again. So I've captured the public IP address that has been assigned to this instance. Now, if I were to actually stop this instance, that means I'm releasing my hardware resources back to Amazon. So in this case, what has happened is the private IP address remains the same, but the public IP address that was associated with this instance, you lose the affinity to it. So if you stop an instance and start it again, your instance would lose the affinity to the public IP address that it was assigned to it earlier, and the instance would get a new public IP address assigned to it. So this is something that is controlled by Amazon by default. And there are ways and methods. Let's say you want a static public IP address. So there's a way to do it. And that I'll be demonstrating in one of the demos today itself. So if I start it, so this time the public IP address that has been assigned should be different. So this is a different address than the one that was assigned earlier. So directly or indirectly, you will be tested on this behavior, that what would happen if you stop the instance and start it again. So public affinity to the public IP address changes. So we've seen the demo of creating a custom AMI. And in the next part, what we can do is we can provision a Windows instance. So I'm picking up a lightweight Windows instance, which is 2012 base edition. So rest of the steps are pretty similar. So we'll pick up an instance type, configure instance details. So we'll keep it as same, then add storage to this instance, apply the security group. So in this case, let's say app security group. Since this is a Windows terminal, we'll be using RDP to connect, and that works on 3389 launch, and then associate this instance with a key pair. So we'll use the same key pair that we created a while back. So the instance is running, and in this case, we'll be using the private key file to generate the admin password for us. So the way to do it is go to connect, select the instance, go to connect, and then get password. So typically it takes about 2 minutes or 3 minutes for the service to generate the admin password for you. Just specify the key pair path and decrypt password. So this is the password that it has generated. So to connect to this instance, I'll be using the default Windows client. So you now have access to a Windows terminal, and you can perform any actions if you want to use Windows IaaS on top of it, any specific middleware applications that you may want to use. So the process of you need to have a baseline understanding of Windows on how to perform those steps. So we have seen 3 or 4 demos on provisioning Linux and Windows instances. So essentially, the process is the same. The method of connecting to each distribution is a bit different. Otherwise, at the OS level, you need to have, or the guys working for you need to have an understanding on working on that operating system. So one thing on security groups before we move on. Okay, so this is working. So earlier, to control inbound traffic, we had said we are allowing access on port 80 and port 22. So let's say I was to X out both, or rather HTTP access to this. So now if I was to access it, this should not be available. So this means any changes that we apply to the security group, they are applied on an immediate basis. So you can expect a scenario-based question that we make changes to the security group and what is the overall impact. So the changes are immediate in nature. Another thing that we said was that security groups are stateful, which means that if you have allowed traffic in the inbound traffic, the return traffic would be allowed by default, regardless of what the outbound rule says. So let me see if I'm connected to the right instance. So now if I want to access traffic outside this instance, so let's say, so I'm able to access. So this refers to the outbound traffic. So if we take a look at the outbound traffic, all traffic is allowed by default. So you can actually change that. And it's always a very good idea that you do not allow any traffic generated from that instance to go outside. So what I'll do here is I'll just simply go ahead and kill this rule. So now I am not able to access any resource outside the instance, but I was still able to SSH into this instance. That's simply because in the inbound rules, I've specified SSH access is allowed. So this is where the term stateful comes into play, that if you have set up an allow rule in the inbound rules, the return traffic would always be allowed regardless of whatever you say in the outbound traffic. So right now, no outbound traffic is permitted. And even if I try to access the web page, I'll still be able to. So this is always a very, very good practice. Even if a hacker was to get into your compute resource, since you have already set it up that no traffic generated from that instance is allowed outside, you are looking at a good security option for your compute resources. So moving on, we'll talk about hardware tenancy. So when we provision an instance, we have an option to choose the tenancy. So what does tenancy mean? So tenancy in this case means that whether you're willing to work on a shared tenancy or a dedicated instance tenancy or dedicated host tenancy. So let's say I pick up this AMI. So you have a tenancy attribute out here. So the first one and the default tenancy that is selected is shared tenancy. And how this works is in the background, you would have a physical host. This physical host in the shared tenancy model would be shared across multiple AWS customers. So let's say I have provisioned 2 instances. There could be another AWS customer who could be assigned this physical host. So this is the shared tenancy wherein the underlying physical host is shared across multiple AWS customers. So this is the cheapest options of all. And for lower environments, it's a great fit. Also recall that when we talked about the stopped behavior of when you stop an instance, it loses the affinity to the public IP address. So there'll be thousands of physical hosts with Amazon. So let's say if I was to stop this instance, I'm releasing this capacity from this physical host. So this is gone. So when I start it again, it is likely to be provisioned onto a different physical host. So in the background, it loses the affinity to the physical host. So I'll come back to this reference when we start talking on EBS because there's an option that you can use out in the shared tenancy attribute. Then you have dedicated host. So in this case, what would happen is Amazon would allocate dedicated physical host to your account. And You have a dedicated physical server to your account, and you are responsible for provisioning your instances on top of that physical host. So in this case, in the case of dedicated host affinity, your affinity between the host and instance is always maintained. And you additionally get visibility to various other parameters such as number of sockets, cores, and host ID. So specifically, if you want segregation at compute layer, you can opt in for dedicated host model, wherein you would be assigned dedicated physical host, and any resources, any compute resources that you provision, you can provision them to your that specific physical host. So this allows you to maintain the affinity between the host and instances. So specifically for PCI compliance, they actually look at dedicated physical host kind of a model. And they have added a variant between shared and dedicated host, which is referred to as a dedicated instance. So in this case also, Amazon would assign a physical host to your account. But the major difference is that the affinity between the host and instance is not maintained. So let's say this was the physical host that was assigned to me. So based on the capacities that were available to Amazon, Amazon might have dedicated a physical host that is much higher in capacities. So that is lost of dollar value to Amazon. So in that case, Amazon would go ahead and dedicate a physical host to your account. But when you stop the instance, so it would again check whether it has a physical host of lesser capacities. If it has, it is likely to place this instance, the next physical host. Again, this physical host would be dedicated to your account. So if your need is purely from compliance perspective, dedicated instance is the way to go. With respect to dedicated hosts, there's another benefit. So there are a lot of licenses that you actually are tied to specific physical hosts. So if as an organization you have already spent money on those licenses, you want to use them in AWS environment, you can always use that. So the default tenancy attribute is shared. That's only eligible under the free tier. If you choose dedicated or dedicated host, you'll be charged for it. So I guess that concludes the session for the day. Thank you very much. Bye bye.